Okay, so let's continue where we left off yesterday. I think, let me open the file. I just opened that. Where is it? Yeah, it's fine. Okay, so we were discussing about our Seaborn library. We discussed, prior to that, we discussed our Matplotlib library. Okay, how can we customize the different plots and everything? We discussed that. And then we explored one data set, which we imported the inbuilt data set from the Seaborn library. That was a tip data set. Okay, and we explored it. What is the shape? What is the information available? Are there any null values? Then we use heat map, right? Means converted our numeric values into some color representation, right? Then we saw what is the correlation between the columns. How can we use the correlation? How this value is computed? We saw the formula of Pearson correlation coefficient and how we converted these values into again the color representation using heat map. Uh, then we discussed that we will do univariate analysis and bivariate analysis. In univariate analysis, we'll do only analysis of one variable. In bivariate, we will do the analysis of bi means two variables at a time. Okay, and how can we do analysis of what is univariate, what is bivariate? We discussed small example we saw. Okay, then we discuss when we have suppose two numeric column and that two numeric columns are floating point data. Okay, for those two floating point data, what kind of graph you should use? You should use scatter plot. We saw that if we have a two floating point columns and between them we want to find out what is the kind of relationship they are having, we can use scatter plot. Then we saw that there is also a plot known as joint plot, which will give us two plots basically. One will be histogram of those numeric columns. Again, the joint plot will be used for the numeric columns. So you will get one scatter plot. Okay, and also beside the scatter plot, you will also see corresponding histogram so that you can see the distribution, how my data is distributed. We saw what is the histogram and everything, right? We saw an example. And then we saw different options, but we can have inside that. We have an option of kind, means what kind of shape you want. So I just put a hex here. So we were seeing hexagon, and by that, we're coming the information that most of the data is considered where the darker range is lying. Okay. Similarly, we saw that we have to find out a linear relationship between the variable that we have passed here, tip and tips, and we can put kind is equal to regression. That is regression. So it will find a best fit line. Okay, then we saw the describe method. Again, describe method is for your univariate. Every column's individual information you can get. Means how many values are there, what is the mean value of that column, standard deviation of that column, minimum value, 25 percentile, 50 percentile, 75 percentile, max, right? Individual column you can analyze from the describe method. Similarly, pair plot. In pair plot, of course, you have several columns available. So if you're going to do analysis individually, it will take a lot of time. So sometimes people do one thing, let me put a pair plot. Automatically, it will pick the columns. And after picking the column, it will find out between pair of columns, the relationship. Okay, so we saw that how can we obtain the pair plot. And I also see, suppose within the same pair plot, we want to see the effect of any categorical column. Okay, so we use a pair plot and we see the effect of sex column, which is having males and females. So this graph that we were seeing earlier, only everything was dark blue, dark blue, dark blue, that get divided into two parts, blue and orange, as per the males and females. We saw that, right? So we can analyze the trends. Similarly, we analyze the same graph with the help of smoker, one more categorical column, right? Then we saw what is a line plot, and we discussed when actually the line plot should be used. When on the x-axis you have some trend data, okay, some trend like year or date or month. For that purpose, actually line plot is better, not for this kind of plot that we are seeing right now. Okay. And then we saw how can we obtain the histogram with the help of distribution plot. So for this numeric column, that is a tip, we saw the corresponding histogram, but in it also one more graph was coming known as KDE plot, that is your kernel density estimation graph, because of which is nothing but giving you probability distribution. Okay, and the value of probability lies between 0 and 1. That's why the scale was lying between 0 and 1 only. So but if we make KDE is equal to false in the next graph, okay, this graph will be gone, this KDE graph will be gone, and your proper frequencies will be appearing in your histogram. Okay, simple. So we just made KD is equal to false. Similarly, we see if we just want to obtain KDE plot, then we can use SNS.KDE plot and pass over any numeric column here. So corresponding KDE plot you will see here. Okay, which will also give you all the values. So most of the values are lying here. Okay, most of the values are, the highest probability is where the values are lying between somewhere near 2. Okay, somewhere near 2, which is the highest probability. So from this, at least you can guess one thing. If by looking at the graph, maximum points are lying here, so that means it has the highest probability. So somebody asks, okay, what will be the tip received? Can you tell me? So from looking at the curve, you can say the probability highest is of which number? 2. So probability is what? Highest is of 2. So means maximum time, the tip that you will be received will be around 2 rupees. Okay, so we can find out the trends quickly. Okay, now let's explore further. Let's pick some categorical data. Okay, let's pick some categorical data from my data set. Okay, uh, just a second, put a comment, execute, and let me again read here df.head just to see the data set. Okay, so we have categorical column like sex column, right? Smoker, day and time. I want to analyze those. Okay, of course they don't have any numeric data, so I want to find out how many males are there, females are there, right? How many smokers are there, non-smokers are there, how many means which days are there, how many Sundays are there, Mondays are there, right? Like this. What is the time, means in time column how many values are coming and appearing. Okay, and what is the maximum time people are coming for lunch, dinner, or breakfast, whatever is this. Okay, so I want to analyze some categorical data, right? This dex, a smoker, sorry, sex, smoker, day and time. So let me pick one by one. Okay. So suppose I want to know in this particular column, how many males are there and females are there. So what I can do, I can use df. What is my column name? Sex. Okay. What I want, how many males are there and females are there. So I can mention value underscore counts. Okay. Value underscore count. It will tell me, okay, how many categories are there in every category, how many rows are there. Okay, in this particular column, how many categories are there? Means, for example, right now we can see male and female, but it may be possible which rows which are not visible here, they may have different values. So from this, we'll see how many values are there. Okay, and at the same time, okay, for every value, how many rows are there in data set. Okay, let me execute this. So it is telling me your data set is having male and female, only two categories. Males are 157 in numbers and females are 87 in numbers. Means the data set is having 157 about the males information and 87 about the females information. Awesome. Now, if you want to plot it within one line, you can plot it without even using your Seaborn library. Directly, I can plot. I can copy this, okay, and I can mention directly what dot plot dot par. Same values means I want to plot these values. So I get some graph. Males are same, almost near 160, yes, 187, and females are around 85 something. From this graph, we can look it up. Yes, 87 we are having. Of course, males are larger in number, right? Males are larger in number, but this graph doesn't look good. Okay, so let me obtain same result, but with the help of Seaborn this time. Okay, so right now this graph that you are using is using directly using pandas. I don't use any other library, right? So now let me use it. So for the same purpose, in Seaborn, what allies we gave, remember SNS. So SNS dot count plot. Okay, I want to count, I want to display actually the count of, understand, I want to say display actually the count of different categories in particular column. Okay, so I mention SNS dot count plot. Which column you want to see? Suppose same column. So you mention sex column. Okay, from where you are picking the sex column. So my data should be my data frame name. What is my data frame name? DF. Let me execute this. And if you can see, I get little bit better colorful graph, right? See, this is very, very dull sort of graph. This is that I'm getting the default graph, which is available in the pandas, which is based on matplotlib. But when I'm using this graph, using Seaborn, I'm getting colorful graph. And you can imagine this is looking much better than what you are seeing there, right? So easily obtain the same graph here. Okay, you want to pick any other column? Yes, you can pick once again. Any other column you want to, and entirely your choice. Example, same another categorical column. Let me pick smoker and non-smoker. Let me check. Okay, means smoker are more or non-smoker are more. So what I can do again, I can copy the same thing. Instead of sex, I can mention smoker here, just smoker. Execute. So two kind of persons are there, whether they are smoker and non-smokers. Of course, non-smokers are larger in number in comparison to smokers. Okay, larger in numbers. Easily we are coming across. Okay, they are very much larger in number in comparison to smokers. Similarly, another categorical column is what? Day. Let me check. So SNS, again, I'm pasting it. And instead of sex, I'm mentioning it. Day. So we have 4-day data: Thursday, Friday, Saturday, and Sunday. And of course, most of the people visited on which day? From this graph, what conclusion you can make? Everyone, what conclusion you can make?
There were more people on weekends, Saturday and
Yes,
Sunday.
yes. Saturday and Sunday have the more, and more on Saturday, and more on Saturday. Highest on the Saturday, least on Friday, least on Friday. right? Actually, it will impact everything. Understand? In such scenario, of course, how my machine learning model gets trained, it learns from experience, from historical data, right? So if you have less historical data, of course, your knowledge will be less. If you have large historical data, your knowledge will be more. Why industry people pay more to the experienced people in comparison to freshers? Why? What difference they have got? Same brain is there, everything, but they have experience, right? What to handle the pressure situation, how to handle the deadlines, everything, how they know by their experience. Same thing is the machine learning. They learn from the experience, that is history. If something history is very less, of course, their learning will be very less. Okay. So of course, if I'm going to train this data, guaranteed my result will be very much better in Saturday because we have more number of rows on the Saturdays. Okay. And we will have, if you talk about the performance, of course, my machine learning model will not predict that accurately on Friday in comparison to Saturday, because Saturday we have large number of rows available in my data set, large number of rows available. So of course, large experience is there. Here, smaller experience is there. So always check whenever you, that's why the data visualization becomes very much important. Your EDA becomes very much important to understand the requirement. Always consider, after even training your model, consider the weakest link. Tell me, you see the data, note it down somewhere, okay? In Friday, we have lesser number of rows available, okay? Means less experience. When your model is trained, always put a data on your weakest link, that is Friday, and check whether it is able to predict correctly on the Friday or not. Let me verify. Okay, and accordingly change your machine learning model or retrain or retrain, whatever you want to do. That's why analysis becomes very, very, very important. Okay, analysis becomes very, very, very important. Understand everything, right? So that you can answer your boss why my model is performing well on Saturday, why not on Friday? How will you answer until you have gone through the data set properly? You have gone through the data set, you will say simply say, sir, Saturday rows are more and Friday data is less. So we'll see that also. How can we make it balance as well? We'll see that. Okay, how can we make synthetic data set? Synthetic, right? Ourselves. Now let me move ahead. Similarly, let me pick any other column. I think time. Let me check time. Means people came for lunch, breakfast, or dinner. Let me. I don't know even breakfast is there or not. So again, I'm copying. I'm just changing it to time. Okay. So only two times are mentioned here: lunch and dinner. So most of the people visited when in the dinner time. Okay. Normally it is the case also. Lunchtime people very less time people visit in the restaurant in the lunchtime. Most of the time they go for the dinner. So of course my result is there the same way. Okay, I'm getting quick insight, very, very quick insight, quickly and beautiful insights we are obtaining here, right? If you want to change their orientation is here now. On x-axis we are getting lunch and dinner, means yes, by default it is x-axis. I want to change it to the y-axis, then I can do that. Here I can mention y is equal to time, like this. If you see, my plot has shifted this way. Now on y-axis I have time, that is lunch and dinner. On x-axis I have the count available, but it looks better for me, right? Everyone, it looks much better than in comparison to this what you are seeing here, right? So, but you have an option. You want to switch the orientation, what you want on the x-axis, what you want on the y-axis. Of course, you can change with this parameter y. Clear, everyone? So far, whatever we are doing, these are univariate analysis. Only one column we are putting here every time. See, sex only we put, smoker only we put, day only we put, time only we put. But sometime what will happen? You want to do bivariate analysis. Okay. Suppose example, you want to see the impact of sex on total bill. Okay, you want to see the impact of sex on total bill, means how the gender will impact my total bill. So what that purpose means, you need a numeric column. This total bill is your numeric column, right? And this sex is your categorical column. Okay, so my requirement is categorical column versus numeric column. For such thing, we have a graph known as bar plot. Okay, we have a plot known as bar plot. What is that? I will mention SNS dot bar plot this time, right? SNS dot bar plot. Okay, and here I mention on x-axis, suppose I want it's your choice, whatever you want, male or female, wherever you want. Suppose I mention on x-axis I want sex column, on y-axis I want total underscore bill. If name is correct, let me verify. Yeah, total underscore will be fine. Okay, and data should be df. Come on, come on, come on. Data should be df. Okay, I just put this. Let me execute this and see we are getting information here. This on x-axis we have male and female, means my sex column. It has two categories, so males and females, and this is total bill. And here you are seeing an average bill or the mean bill that is available here. Okay, mean bill or average bill paid by the males are more than the average bills paid by the females. And of course, the reason is don't come to the conclusion. Don't come to the conclusion immediately. Okay, why? The reason is obvious. See here, males are larger in number, right? So of course they are larger in number. So when you will find the average, okay. But of course it will be impacted. But don't rush to any conclusion. Always analyze every possibility. Always analyze every possibility. Okay. Although the average, you will calculate how you will calculate total sum, total bill paid by the males are divided by total number of males available. Similarly, how will you find the average bill for the females? Total bill paid by the females divided by total number of females available. I repeat, how will you calculate for males? Total bill paid by the males, all the males divided by number of males. How will you find the average bill find out by the females? Total bills paid by the female divided by number of females which are available. Okay, so analyze every aspect of what we are getting here, right? So males are more, females are less. Okay, and from here information is also coming. What your males paid more average bill in comparison to females. And what conclusion you can make? Females spend less, and it's obvious. It's obvious. Okay, let me give an example. You will laugh at me. I was coming from outside yesterday. Okay, that's why 2 days was off. So I had a taxi. Okay, and I booked it for 2,500 from Mathura to Agra. I wanted to go there, but on Ola and Uber, right? On Ola, that was costing 2,400 rupees. My wife checked that. I didn't check that. I hired external people was visiting there, means to travel agents for visiting there. I booked my cab for 2,500. Okay, my wife was behind me. She was carrying some luggage, so she entered to see how much you have booked it for. So I said 2,500. So she said, no, 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 we won't spend 2,500. We will spend only 2,400. We will save 100 rupees, right? So normally it's obvious increase in that females spend less, at least on something. On jewelry, they can spend huge amount of money. Okay, on their shopping, they can spend huge amount of money. When something comes like this, traveling and everything, where money has to be saved, of course they spend less. And same thing is reflecting here as well, right? We can witness that. So for what we can conclusion we can make from here, your males paid more average bill in comparison to females. Okay, simple. Again, we can put any other column, any categorical column if you want, right? We can change the orientation as well. Suppose, okay, we can change the orientation by switching X and Y. Suppose I do this thing, Y, and this X. See, result will be same. Just orientation has been changed. But I think this is looking better. But yes, options are there because sometime when you are presenting to your boss says, no, no, I don't like this orientation. Please change the orientation. This should be on this axis. This should be on this axis. So you have an option available for the same. Right? Similarly, you want to see the impact of total bill on any other thing, suppose any other category. Let me come here, suppose, or tip, anything we can pick. Suppose I'm seeing SNS dot bar plot again. And this time I want to see the impact of X is equal to 6 and Y is equal to, suppose, tip column. Okay, so I want to see the impact of sex on tip column. Means, is there any difference? Means, what is male and female wise? Means male pays more tip or the female pays more tip? Let me verify. What is the average tip paid by the males and females, right? I want to see, is it any impact? Data is equal to TF. See, again, the males paid more tip. Okay, average. This is the average thing that you are seeing here. This is the average tip paid, average tip paid, or the mean tip paid. Okay, again, the tip paid by the males are higher in comparison to tip paid by the females. So any categorical column, any numeric column, you can pick it up here in the bar plot. One is category, one is your numeric column. See here also, one is category, one is your numeric column. Okay, further, you can do this thing, SNS dot bar plot. I want to see the impact of, suppose, sorry, Impact of smoker on, let's say, tip. What is the impact of smoker or non-smoker on tip? So I mentioned here smoker. X should be smoker and Y should be tip. Okay, tip. And data set should be data is equal to DF. Okay, so no much impact. Can you see they are parallel? No impact on the tip. Okay, no impact on the tip, whether the person is smoker or non-smoker. So it doesn't impact anyway. Can you see everyone? Please see. Is there any difference in the average tip paid by the males and females? Oh, sorry, by the smoker and non-smoker?
No difference.
Right? There is no difference. So what important conclusion this means? It will not impact. Don't worry. It is not going to impact anything. I mean, this is male, but whether the person is smoker or non-smoker, it is not going to impact how much tip he will pay. Okay, it is not going to impact at any cost. Right? And such kind of column, when it is not making any impact on my output column, that is a tip column. So we can drop such column. When it is no impact, then what is the point of keeping it? What is the point of keeping it? Okay, but don't rush into the conclusion, right? There can be further thing. Analyze completely when all the analysis has been done, then see, okay, whether it is needed or not needed. Accordingly decide. Okay. Similarly, we can put any other thing. Okay. And let me check this time. Total bill on the basis of day. On the basis of day, right? Means what is the impact of day on average tip paid? Impact of day on average tip paid, right? Let me go here. On Sundays, you can see the average tip paid on the Sundays was more in comparison to Saturdays and Fridays and Thursdays. Right? On Sunday, the tips are more. Average tip paid are more in comparison to Thursday, Friday, Saturday, and Sunday. Awesome conclusion. That's very good. Right? Again, we can pick anything else, any one time. Let me pick time here. Okay. So in dinner time, average bill paid is more in comparison to the lunch time. Okay, awesome conclusion we are finding out. These are the finding, right? You can suggest your boss the finding, what finding I'm getting from here. Clear, everyone? Please tell me.
Yes, sir.
Okay, so now let me move ahead. Yeah.
Sir,
Yeah, please.
I wanted to ask one question. You said that black marker, that black line, small line, is indicating average.
This one is that no, this is not black line. This is just an indication what it is coming here. Okay, this
Huh.
is this line is average. This wherever it is coming, maximum that value is seeing here. This
But
is your average value.
that will be a maximum value, right?
No. That is average value. Average value of the tip, not maximum value. Average value. Let me show you. Let me show you. See, if I do this thing, the df dot group by. Okay, and let me do group by which column we are using. I think what is the column? Time. Okay, let me mention here time. Okay, and what I want to find? I want to find mean or average value. Okay, what column it is this? It is tip. Okay, if you see at lunchtime, the tip paid is 2.72. Can you observe, sir, here?
Okay.
Right, and at the dinner time, the average value is above 3. That is around 3.10.
Okay. Yes.
Okay, this is the thing, sir. Okay.
Okay, sir.
Yeah, so this is the whatever numeric column you are picking, by default it gives you mean value. By default it gives you mean value only. Okay, let me come here. But we can have the change the option. We don't want to see the average value. We want to see the maximum value. We want to see the minimum value. That we can also do. I'll tell you that. Don't worry. We can see that as well. Means instead of seeing the average value, you want to see something else. Max, min, okay, or whatever sum. That you can do that. No problem.
No, actually, what I was having in my mind, whenever normally we plot a bar plot, we plot the actual values against that timeline or actual value against that X variable. So that I was having in my mind.
Actually, by default, it gives you mean value only. Okay, remember here, whatever it is doing, by default, it is mean value, and you can verify from here as well, right?
Okay.
Same thing. Default value is the mean value only.
Okay.
Yeah. Okay, but we have an option of changing it. I'll explain you that. Don't worry. Wait for some time. I think. Can you see? Estimator is what by default, sir? Can you see?
Mean.
Yes.
Yes.
Okay, that's why. That's why you are getting average value. But we can change it. I'll tell you. Don't worry about that.
Okay.
Okay. Come here. First, let me explore everything basic so that I can tell you what changes we can make. Okay. Now
Correct.
let me come to next plot. It is very, very important plot that right now we are going to discuss. It is known as box plot or whisker plot. Very, very, very important plot. See what it does. Actually, it gives you a 5-number summary. 5-number summary. What are those 5 numbers? Those 5 numbers are your minimum point. Okay. Your first quartile, that is 25 percentile. Your second quartile, that is your 50 percentile. Third quartile, that is 75 percentile, and the maximum point. Right. So it gives you 5 things: minimum point, first quartile, second quartile, third quartile, and maximum point. Okay, let me show you that. That way you will understand better. Suppose what I do, I pick a numeric column. Okay, I pick a numeric column here, and I'm gonna say SNS dot box plot. And it is very important basically to find out the outliers. Immediately from this, looking at the box plot, you can identify what are the outliers available inside my data set. Okay, so SNS dot box plot, and I mention here example. Directly total. Let me put total bill first of all. Let's see what the orientation will come at the x-axis. I don't want that. So let me make it on the y-axis. Y is equal to total underscore bill. Okay, and data should be equals to df. Okay, let me execute this. Can you see this is the graph that you are getting is nothing but box plot. The graph that right now you are seeing is your box plot, right? It is your total bill which is available here. And what it is showing, see this one. This is your minimum point. This is your minimum point that you are seeing here. This is your first quartile or 25 percentile. This is your 50 percentile or second quartile. This is your third quartile or 75 percentile. Let me mention this. This is minimum point, min. This is 25 percentile, not percentage. Okay. This is 50 percentile or median. Okay. This is 75 percentile. Okay. And this is your max value. So whatever points that you are seeing here, these are your outliers above the max. Anything above this max, anything below this max, if you are seeing, so understand those are your outliers. Okay, and what are outliers? Explain. You remember in organization you are working, you are having suppose 52 employees. In the 52 employees, your 50 employees are having salary between 25 and 30,000. Okay, but 2 employees are having salary 5 lakh rupees per month. Right, so those 2 persons are not above, means different from the trend. Outliers are nothing but different from the trend. That is the only outliers. Something different from the trend. Trend is between 25 and 30,000. Those 2 people are having salary 5 lakh, 5 lakh. So those are what? Outliers. So this thing is what you are seeing here is what? Outliers. Okay, and how we will find out these outliers? This is your maximum point. This is 75 percentile, 50 percentile, 25 percentile min value. Okay, so this is also known as your third quartile, Q3, middle one known as Q2, and the 25 percentile is known as Q1. Okay, and the difference between Q3 and Q1 is known as IQR. Remember, IQR, that is interquartile range. It is known as interquartile range. I repeat once again. It is known as interquartile range. Okay, so how will you find out IQR? Somebody asked you in the interview, what is IQR? You will say interquartile range. And what is the formula for the same? Nothing but Q3 minus Q1. Right now, in an interview, they ask, tell me what is the maximum value. So what will be the maximum value? Maximum value is computed like this. Understand everyone? Very, 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 very important, because according to that only, you will find out your maximum value. What is the maximum value? Maximum value is, let me mention this way, clean this. Yeah, let me mention here. Your max value is nothing but Q3 means this point, Q3, whatever is Q3, example, this is the value of Q3. plus, we are going upside now, so we'll plus 1.5 times of IQR multiply by IQR like this. So this is your maximum value, Q3 plus 1.5 times IQR. Similarly, what is the minimum value? Minimum value is Q1 minus 1.5 times IQR. IQR. Okay. So in interview, very commonly ask you first, do you know what is IQR? You will say, yes, sir, interquartile range. It is nothing but difference of third quartile minus first quartile. Okay. How the maximum value is calculated? We'll say Q3 plus whatever is the value of Q3. Add to this what? 1.5 times of IQR. Whatever IQR you are getting, 1.5 times add to Q3. That will give you maximum value. What is minimum value? You will say, sir, whatever is the value of Q1, subtract from this what? 1.5 times of IQR. So we'll come here. Okay. Anything below this minimum value, anything above this maximum value will be known as your outliers. Okay. Now, how will you compute? From this, you can see, although, okay, or you can get the same information from here as well. See, if I close this and execute this, mention this df.describe. Okay. What is the column we have used? Total bill. See, the total bill, this is your 25 percentile. Okay. That is Q1. That is your Q1. What is your Q2? Q2 is this 70.79. What is your 75 percentile? This value. Okay. So you have this available, you have this available, you have this available. Okay. So you can compute from this, or otherwise you can do this as well. Let me import NumPy. Import NumPy as NP. Okay. In NumPy, we have a function available for the same. Okay. So I'm going to say np.percentile. Okay. Now, which column percentile you want to find out? So you want to find out the DF total bill. This is the particular column whose percentile I want to find out. Now, which percentile values you want to find out? I want to find out two values. Remember, Q1 and Q3. So Q1 is 25 percentile. Q3 is 75 percentile. So mention this 25 and 75. So it will return me two values. First, this one, and what this one means 25 percentile and 75 percentile. Okay. So first will be your Q1. Second will be your Q3. So it will return two values. So I can mention here. First one is Q1, comma. Second one is Q3. Because first is 25 percentile, second is 75 percentile. Let me execute this. And now if we can check Q1, 13.34. Can you check everyone? Right? What is 75 percentile? Q3. Check what is 24.1274. Right? So we got Q1, we got Q3. Now I can find out IQR. What will be IQR? IQR will be
Q3 minus Q1.
Yes, Q3 minus Q1. See, this is my IQR. 10.779. Now I want to find out maximum value. So we know what is the maximum value? Max value, or we can say max underscore value, or maximum directly we can mention maximum equals to what? Remember what I mentioned? Q3 plus 1.5 times of what?
Sure.
IQR. This is my maximum value. Minimum value, minimum is equal to Q1 minus 1.5 times of
IQR.
Right? So if I execute this, let me check my maximum value. 40.29, right? Minimum value minus 2.882. Perfect, no issue. Now come here. From this, you can check. Oh, sorry, not from this, from this. Okay. In negative side, we don't have any data points available, right? Which are below this minimum point. So no problem, there is no outlier. But here we have an outlier. Okay. So I want to filter my data frame so that it should not have any outliers. Okay. And how can I decide that? Anything in the total bill column which is above what? 40 point something. It is the maximum value now. See, same I'm getting. What? 40.29. So anything above 40.29 is what? Outlier. Right? Or anything below 40.29 is perfect, right or wrong? Anything below or equal to 40.29 is perfect. So what I can mention here, see, I can mention this way. DF of total bill should be less than or equal to what? Maximum, right? Should be less than or equal to maximum value. If I execute this, I will get true and false, right? Let me execute this. Every value of total bill will be checked. It will be giving me true and false. See, whether it is true and false. Okay. And now remember, how do we filter our data frame? What I can do, I can pass this condition inside my data frame like this. Now, my only those rows will be selected in the data frame which are satisfying this condition. Right? So you will be getting only those data which is not having any outliers. And you can save this result anywhere else. Suppose DF1. Done. Okay. And now let me come here. Check your DF1. So some rows have gone. And you can check what, see, df.head or df.shape. 244, right? Check this one, df1.shape. How many rows have gone? Can you see, observe everyone? There are 9 rows which has removed, which were what? Outliers. Clear everyone? How to remove this?
Yes, sir.
Right? And similarly, sometime you may have to remove from here as well. In the negative end, sometime you will have those as well. Right? So what you can mention here? You can mention combination here. What? This condition plus one more condition, your AND condition. Now, both condition means here I'm mentioning DF total bill should be less than maximum. There you should mention my DF total bill should be greater than or equal to minimum, and AND operation of those. Right? So you want to mention in either you can do in 2 steps or better you do in 1 step only. Directly mention total bill should be less than or equal to maximum value, and total bill should be greater than or equal to minimum value. So only and only you will get those rows which are not having any outliers. Clear everyone? Please tell me.
Yes, sir. Clear.
Okay. Yeah. Okay. Perfect. Now let me move ahead further. Okay. Now I'm coming here. So far, I just use one column, right? I use one column, and on one column, I did the study, right? I can use total bill. I can use total and tip as well. Example, I can pick this and mention here example SNS.white clause instead of total bill. I can pass here any numeric column like tip. I will get the information from here as well, right? Are there some outliers or not? Okay, so we can remove this. I know now you know how to remove those, right? Now we know the process how to remove outliers from this. We'll again calculate what is mean value, is percentile, is first quartile, is third quartile, then correspondingly IQR, and after the IQR you can compute easily maximum minimum value and remove the outliers the way you want. Right? This is the way to do this. Any numeric, any column you can pick and work on the same by removing the outliers, right? Now see what we are happening. We are seeing example tab, or we are seeing right now individual column. But let me see what is the impact of any category on this column in terms of box plot, so that we can see outliers individually wise, category wise. So again, I'm going to say SNS dot box plot. Okay. And suppose I want to see the impact of sex. So I mention X on X axis, I want sex. On Y axis, suppose I want total bill, total underscore bill. And data should be suppose DF. So instead of only box plot, now you will get 2 box plot. One corresponding to males, one corresponding to females. See? And there also, in males also we have an outlier. In females also we have an outliers. Right? So we can individually analyze that better. Very, very easily we can analyze them better. Very quickly. Right? Any other information, suppose I want to see the impact of any other thing, suppose a smoker and non-smoker on total bill. So I can do that, smoker. Again, get an information. This is smoker is yes, and we have less outliers in case of smoker, and more outliers in case when the person is non-smoker. So we can remove those. That is actually very, very important. Individual category wise, we want to do that. Very, very, very important thing, right? Similarly, I want to see the effect of third category as well. Suppose, okay, sorry, second category. One category is smoker, one is total bill. I want one more thing. So what I can do? See, I come here. And suppose I mention here, let me do one thing. Before that, let me mention day here. Day is also a category. So Thursday, Friday, Saturday, Sunday, right? So we are able to see again very quickly which is the main source of outliers. Accordingly, we should remove those. Okay, easily we can remove those, and we can filter out our data frame if you understand properly. Okay, anything above 30 on Thursday will be what? Outliers. Anything over 30 on the Thursday will be outliers. You can filter your data frame by passing the condition. Day should be Thursday, right? And your total bill should be less than
30.
Done. Similarly, your day should be Friday and total bill should be less than 40. Instead of directly looking at, you can also make a decision. Instead of doing this, calculating IQR and everything, maximum, minimum, by looking at the graph, you can directly make a conclusion. See here. So we need the values less than 40. So anything less than 40 will be my desired data without outliers. Directly we can see from the graph itself. Okay, anything below this or anything above this is my desired data. So you can filter out accordingly without even calculating this thing, right? So same thing you can filter out here. Okay, now suppose I want to see impact of one more category column. Let me copy this. Okay, so this is day versus total bill. What I want to see in the day wise also, I want to see the impact of males and females further males and females. So that is a category once more. So I can mention here hue is equal to, okay, and here whatever column you want, suppose I mention my column name is to be sex column. So further your graph will be divided. Even on Thursday, see males and females. On Friday again, males and females. Your blue are male and orange are females. Again, Saturday, males and females. On Sunday, males and females. So further analysis you can do, which is giving you proper information. So more deeper you go, more insight you will get. And that's why I told you, while you are building with machine learning models, 70% of the time they spend in EDA and data pre-processing by understanding the data properly. Devote time, understand what we can do, what is the possibility, what is the relationship, how can I deal with this, what is the source of an error that may be possible. Everything, analyze as much time you can spend that you can do this. Right? We are just learning the graph this time. Suppose if honestly, if you give me this data set, I will take at least one day, only one day, complete one day, 8 to 10 hours on analyzing this data set only. One complete day. Analyzing every possible relationship, analyzing every possible means how can I extract this information, what insight I'm getting from this, so that I can build my machine learning model very, very, very well. Okay, and that thing will come with a practice. The more practice you will do, more sound you will become, without any problem. Right? Now, similarly, let me come here. Okay, very much similar to your box plot. Actually, there is one more plot known as violin plot. But basically, it's a combination of two plots. Combination of your box plot and KDE plot. Okay, box plot and KDE plot. KDE plot, remember this one, if you can remember.
Kernel density.
Yes, kernel density estimation. This one. Okay, so it's a combination of these. So what I can do, let me pick the same graph, any graph, we can pick it up. Where is? Yeah, let me pick this one. Okay. And instead of box plot, I would just mention here what? Violin plot. That's it. So we'll see two graphs in one visual. Box plot plus KDE plot. Although, honestly speaking, rarely you are going to use this. Rarely. I don't think so you will be using them anytime, right? Because your work is done by box plot better, because when you will be seeing your violin plot now, you will be not be able to see properly your box plot. Let me show you that. With the example, you will see better. See, I'm getting violin. The shape is like violin. That's why you're seeing this. Okay. So in between, what you are seeing is your box plot. This is your box plot in between. Right? And these are what? Your KDEs, kernel density estimation curve, which is saying what? For the males, okay, the what is the maximum value we are having? You can observe from here, where the maximum values are concentrated around this 20 point something for the males, right? Similarly, for the females, where the maximum values are concentrating around this one. right? So this is what, again, a distribution of which showing you total bill distribution. So total bill is distributing where? Towards around 18 or something. Maximum values are this. I think we can see that as well. If I plot SNS dot KDE plot, okay, and here I mention, suppose, let's say total bill and data is equal to DF. Okay, and if you can see from here, can you see the peak, everyone, where it is? Can you observe, please? Okay, and if suppose I mention here, now can you see better, everyone? Please see the graphs. Observe, please. And instead of KDE plot, what you can see better, you are seeing total bill they are showing. Use your dist plot. That is better because that will show you the better values. Dist. Okay. What is that? Next is it. Okay. Let me do one thing. DF. Oh, it doesn't support hue. No issue. See where the main symbols are concentrated, everyone. Can you observe, please? Please see the shape where the values are, maximum values are lying. And let me turn this off, hue, actually, especially KDE is equal to false. What happened? What happened?
Sir, you wrote false in quotation marks.
Oh, sorry. Yes. Sorry. Yes. Now see where the maximum values are lying. See around between 10 and 20 only, right? Between 10 and 20. And if you see this graph, can you observe, everyone, where the maximum value is lying? Whether it is a male or female, right? So combination of what? It is a KDE plot that you are seeing, this shaped curve that you are witnessing here. These are your KDE plots, right? This one are your KDE plots, right? This is just a mirror image of this, right? This was graph and this graph are mirror image. Okay, and this at the top, this in the middle, what you are seeing, you are witnessing here your box plot. Okay, if you ask me personally, rather than seeing this, I like to go for a conventional box plot. But yes, we should know options which are available. What are the different options which are available here, which you can use? Please see, everyone, and you can use it further. For example, same graph like this. Multiple same options we can observe here as well. SNS dot. And just shoot a box plot, I can mention here violin plot. Okay, same. We saw day versus total bill, but with the hue of 6. So we are seeing the same sort of graphs here. Please see, Praveen. That's very, very important.
It's really interesting, sir.
That's very interesting. Actually, it's analysis is very important. Actually, very interesting. Data analysis is very important. If you master pandas and visualization, trust me, most of the work you can do very, very easily. Very, very easily. If you have pandas is also very important. Equally important. The pandas library is equally important. So if you understand the pandas, yeah, you know group bias. How can I find out the insight from the days wise and everything? Both combination will work very, very good. Very, very awesome.
Sir, is there any command where just like bivariate or multivariate analysis, we get all these plots in one and the same window?
Sorry, sir, can you repeat once again, sir?
Just like multivariate analysis, we are getting that correlation coefficient and everything in one particular picture.
Uh-huh.
So is there any such kind of facility over here where we can get all these variations in a single graph instead of doing it separately?
No, sir, I don't think so. You will get symbols, different graphs there. Actually, something is there known as pair plot. If you see there, already we saw that graph. All the multiple graphs are coming there, but not everything was coming. Not everything was coming, right?
Yeah.
Not everything was coming. But what you can do if you don't want to analyze individually, actually, there is a one library known as Pandas Profiling Report. Let me
Okay.
show you that. Okay, there is one thing you don't have to do. You have to just import it. But unfortunately, what has happened, I don't know. I refresh my system. It is not getting installed at my system. This is Pandas profiling actually. Not this. Yes, this one. Okay, there is a particular library. You have to just use it, and automatically, between all the column, it will find out the graphs for you. Just click on the same. All the inside it will generate automatically.
Okay. Okay.
Directly library is there, but unfortunately, it is not installing at my system. Let me copy this. Let me try this. I don't know it will work or not because I've tried several times. Earlier it used to work, but now it is not working. I don't know what's the reason. Maybe the same. Let me do one thing. Let me save it first of all. Okay, and stop it, close it, quit, close this, and let me open Jupyter. But this time, let me run as administrator. What happened? Sorry. Yes. Okay, and let me try. Seaborn, where is Seaborn? Come on, come on, come on. Yeah, this one. Earlier I tried several times. It was not allowing. Let me try once more. Just make it not this. Okay,
Great.
let me try. Yeah, it is done. It has been done. Now let me use this library. Where is the library? Come on, come on, come on, come on. That's fine. That's fine. That's fine. Like
Import.
this. Yeah, like this. Let me import this. Okay. This is the problem that I'm facing. While I'm executing this, it is saying cannot import name ABC index from the pandas code. This is generic. It's not doing that. I don't know. The earlier what was same thing was happening, but it was not doing this. It has been installed, but it is not executing.
Maybe because of that pandas version.
Maybe it may be the reason. I tried, but it is not mentioning any such kind of error here actually.
Because earlier it was showing certain warnings when we had executed.
Let me
So
try
maybe
one.
because of that.
Maybe let me try one more thing. Anaconda prompt. Okay, and let me paste it instead. No, not this, not this, not this. Let me go here. Hmm. Let me see the warnings. Meanwhile, it is doing the collecting the packages. Let me check what warnings I'm getting. Actually, warnings can be ignored. There is no problem with the warnings. Invalid distribution, invalid distribution, invalid distribution. It is ignoring all of these.
That may be due to that version, I think.
Maybe. But actually, it has something like that when it has incompatible version, that it doesn't even install.
Yeah.
It doesn't even get installed, but it is successfully installed. That is the
Because
main issue.
in earlier commands also, it
Mhm.
has showed certain warnings that this time this has been updated, or whatever command we
Mhm.
are giving, it may not be possible in the updated version, etc. So
Okay,
that kind of warning I have seen.
Maybe, sir. Maybe
When you
let
have
me. Yeah. Current user does not have right permission to the target environment. Location does. C program environment condition. Let me do one thing. One more. Yeah. Anaconda. Come on. Anaconda prompt. Run as administrator. Actually, this library will give in one time all the report it will give me. According to it, it has been done. Let me see. Ah, it is done. Awesome. Now done. Now let me do one thing. Come on. Yes. df, let it be. Execute this. df is not defined. Huh? How come? Okay. I didn't import it that. Yeah. Again error. We read the argument inside. Let it be df only. Let's check. There's some problem. I don't know what has happened to this. I will check it, but I don't know. I've been trying to use this, but some reason it is not able to work. Let me see some other option. Not this. Come on. No. Let me check this. There's some problem with this. I told you it is not working in my system. Some reason is there. If it is coming, it is not working. I explored several times, but due to some reason, everywhere I tried every possible option which is available.
Yeah. Okay, sir.
Let me check it again. I'll see there's some option available, but actually it's a good tool. But normally I don't use it. I normally prefer, because going through every individual graph, looking at the inside, that is better. But at least, yeah, we should have an option available. How can we use that? That is always a good option.
Yeah.
We should always
No,
have an option available. Yes, sir.
this method is excellent because in this way we are learning more.
Yes, yes, sir. In this way, actually, only
Yeah.
one line has to be done. Everything will come in one go.
Yes,
Everything will
yes.
come in one go. Yeah. So for shortcut time, you can use it. In
Yes.
shortcut time, you have less time available. Quickly, you want to generate a summary. Then this will give me one report quickly. Okay. I'll try to troubleshoot this problem. Let's see if it works or not, because I've tried several times. It is not working. Okay, let me check it. I'll let you know. Okay. So can we end for the day, everyone? Continue tomorrow. Is it fine?
Yes, sir.
Sir, I'm having
Yeah.
a small doubt.
Tell me, Hardik.
Sir, can we go back to that KDE plot?
Mm-hmm. Uh, this one.
With total, yeah, no, not this. The one with total bill.
Okay.
We did it at the end of the session, just
Okay.
a
Okay.
few
Okay.
minutes ago.
Okay. 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 I think let me do that. No problem.
Yeah.
Mm-hmm. Not taking what happened. Why it is not taking what happened? It's not recognizing, or what happened here? Where is my data frame? Come on. I've read the data frame. Then why it is not appearing? Come on, come on, come on. Spelling is fine. Everything is fine, I think. Just delete this, delete this, delete this. Let me import SNS. What happened? Uh-huh. What
Sir,
happened here?
instead, can't we write just sns.kde plot, then total bill, and then just data equal to df?
That we can do, but it should accept this. It should accept this as well. See, we have done that. If I go back again,
Yeah, I noticed it. We did it
we have
today
done that.
only.
We have done that. So it should have taken that. See, not this. See this.
Yeah.
It's working perfectly. Why it is not taking this time? Same thing is there. Let me just change total underscore L. Uh-huh. Let me do one thing. TLT dot. Again, let me just a second. If you're not taking this way, matplotlib dot pyplot. Ag. Matplotlib is currently using Ag, which is non-GUI backend, so cannot show the figure. I think some other library is working under the hood. Okay, that may be the reason. Let me do one thing. Let me close it and reopen it. Okay, leave, quit, and let me reopen. Quiz. Okay, it should work without any problem. Jupyter. Okay, and where is Seaborn? Mm-hmm. Now let me use. Yeah, yeah. Now it's fine. Yeah, tell me now.
So, sir, in previous lecture, you
Mm-hmm.
told that if we are making any machine learning algorithm, then our graph
Mm-hmm.
should be as close as to Gaussian, and it should not be
Mm-hmm.
skewed.
Mm-hmm.
So, uh, shall we consider it in this graph in category of Gaussian, or is it skewed? Because
Actually,
from the sideways it looks.
it's not perfectly standard normal distribution. It's not perfect, right? Slightly skewed. If you see here, most of the values are considered here, right? If it
Right.
should be been ideal, it should be like this. Somewhere midway, a bell-shaped curve ideally it should be.
Yeah.
Ideally it should be. So little skewed it is. Little skewed that, but we have an option of checking the skewness, and how to deal with that I'll tell you in the data pre-processing section, right? I'll tell you how to deal with this as well. We will do some transformation, and when we will do some transformation, with the help of those transformations, some of the skewness will be removed. Not entirely, but some of the skewness will be dealt with that. Of course, you will be 100% not getting 100% skew free. It's not possible, but some skewness is acceptable. Example, limit is 0.55 normally. Okay, if your skew net
Okay.
is coming above 0.55, then actually there is a problem. Okay, so you should try to reduce below 0.55. Up to 0.55, it is acceptable. This is normal rule, right? But we have different options available for the same. Okay, we have an option available for checking the skewness. For example, if I come here, df dot skew sk, yeah, this method is there, right? It will tell you about the skewness. See, skewness is there. Can you observe?
Yes.
Limit is 0.55. I'll tell you this in the data pre-processing. When you will take a data site, I'll tell you how to deal with this, right? How your log and square can deal with this. We'll solve this problem. Don't worry about it. Right? So we have different method available, but we will do this. Yes, it is not perfect. And we saw from the graph itself, right? Ideally, it should be like this. This from histogram also you can see the information without even using this. You can get the same information from histogram, right? Histogram is also not symmetric. It is here. It should is here, right? Ideally, it should be like this. A perfect bell-shaped curve, something like this. Okay, but right now it is skewed. Most of the values are lying here. Very few values are lying here. This is skewed, as well as if we talk about this graph, one more graph, this is also skewed. Okay, this is also ideally it should be like this. Best for your machine learning model. Best for your machine learning. Fine, Hardik?
Yes, sir. Got it.
Okay, okay. So I'm calling it a day, everyone. See you tomorrow. Okay, bye-bye. Take care.
So please share this
Thank
file.
you, sir.
Yeah, sure, sir. 100%. I'll share. Now it has been almost completed, so I'll share. Definitely. Okay.